Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. The measurement of distance in the context of clustering algorithms are specifically k-means clustering and k-Medordes clustering. They are partition-based clustering. But here's a question. How do we measure the distance? Here we have to discuss different types of data. First, we have fixed distance data, which refers to numeric data that has a consistent and equal interval between successive values. For example, if we have the data representing the temperature in degrees Celsius, the difference between any two values is constant.
Fixed distance data is often used in qualitative data
and various mathematical calculations. Qualitative data, also known as categorical or nominal data, involves non-numerical categories. One common type of qualitative data is
Boolean data, which represent two categories true and false.
Boolean data is commonly used in logic at decision-making, where outcomes can be represented as either true or false. Sequential data involves ordered, discrete values. These values have a clear order or ranking among them, but the interval between each value may not be fixed. A common example is the use of labels like excellent, good, medium, pass, and fail to represent the performance level in the education. While there is an order to these categories, the exact numerical distance between them may not be meaningful. Distance is a measure of the degree of the discrepancies or dissimilarities between data points. It qualifies how far apart or different two points are from each other. The closer the distance between 2 points, the more intimate or similar they are, suggesting that they belong to the same category or cluster. Conversely, the farther the distance or the more distant similar the points are, indicating that they belong to different categories or clusters. In this context, we consider each individual data points as a point in n-dimensional space, where n represents the number of features or variables. To measure the distance between these data points, we need to define the specific distance metric.
Euclidean distance is a commonly used distance metric.
It calculates the straight line distance between 2 points in n-dimensional space. It is calculated as the square root of sum of square differences between the corresponding coordinates of the 2 points.
Euclidean distance provides a measure of the
as the crow flies distance between 2 points.
Squared Euclidean distance is another distance metric that is derived from the Euclidean distance.
Instead of taking the square root of the sum of square differences,
Squared Euclidean distance
directly calculates the sum of the square differences.
Squared Euclidean
distance is often used in scenarios where the actual distance value are less important than the relative distance in between points. Here we look at an example. Think of this case data as a point in two-dimensional space. Define some distance between points.
If we use Euclidean distance to measure it,
we calculate the straight line distance in space between the two sample points. With these sample points, we can calculate the distance between each pair of points and summarize them in the form of distance matrix. If the data differ by orders of magnitude during clustering, it should be normalized. Data standardization is a technique used to remove the influence of varying magnitude in the data.
One commonly used method for data standardization is min-max standardization,
also known as normalization. In this approach, we transform the original data
into a new scale between 0 and 1.
The formula for min and max standardization is as follows. New data equals original data minus the median and divide by the maximum minus minimum. Another common used method is z-score standardization, which calculates the number of standard deviation a data point is away from the mean. This method helps us compare data points on a standardized scale. The formula for z-score standardization is new data equals original data minus means and divided by standard deviation. By standardizing the data using this method, we can ensure that the impact of different magnitudes is eliminated, making it easier to compare and analyze the data across different variables or features. Let's consider an example involving two individuals A and B with their respective personal parameters such as age, annual income, education, and consumption.
Now, we want to calculate their Euclidean distance.
To begin with, we're working in the four-dimensional space since we have four parameters to consider: the age, annual income, education, and consumption. It's important to note that these parameters consist of both quantitative and qualitative data. They are measured in different units. To process this data, we need to perform certain steps
before calculating the Euclidean distance.
For quantitative indicators like education, we need to convert them into quantitative values. This can be achieved through methods like assigning scores or using fuzzy logics. For example, we can assign a score of 60s for undergraduates and 19 to 100 for excellent. Since the units of measurement for the different parameters are different, we need to eliminate these differences. Normalization is used to bring all the values onto a common scale. It ensures that no single parameter dominates the distance calculation due to its larger magnitude. By performing these pre-processing steps, we can ensure that the data is appropriately qualified and standardized, thus removing the impact of varying units. Summarizing the content of this lesson, today we primarily grabbed the definition of clustering, which is the algorithm that automatically categorizes objects. We described the working of the clustering algorithm through several examples. Along with some key concepts within the clustering, we placed emphasis on the concept of distance, and distance calculation plays a vital role in the clustering algorithms. Finally, we demonstrate the application of clustering algorithm using a few clustering examples. This concludes today's lesson.
See you in next class.